Today we'll find out what kind of magic happens in coroutines, and how the language developers manage to achieve such behavior, where a program can exit a method in order not to block the thread, and then return to it starting from the next line. Let's work today in a new package, where we'll study how coroutines work under the hood. So let's name the package accordingly, under the hood. I already mentioned earlier that coroutines are essentially also programming with callbacks, but these callbacks are hidden from the developer. And to demonstrate to you what actually happens, let's bring back the implementation of the loading methods so they work with callbacks. We can just copy the implementation from the package callbacks. We copy the file display and the file test, and paste them into the newly created package. Here it's important to check that the package name matches the folder in which this class is located, and we also check the file test. We see that here display was imported from the package Coroutines. We don't need it. Here we'll launch the display from the same package under the hood. And let's move everything that happens when the button is clicked, the entire loading data process, into a separate function. Let it be private, and we name it load data. And into this function we'll copy everything that happens when the button is clicked. And here we'll just call this function. We paste all the code here. Here we are no longer inside the button scope. We cannot refer to the button using this. So we need to explicitly specify the name of this variable, that we are setting the properties enabled of the variable load button to false at the beginning and to true after the loading finishes. And now let's see how many times the program needs to exit the method load data and return to it again. The first time the method needs to exit is during the book loading. We would like the button to have is enabled set to false. The text shown that the book info is being loaded, then book loading should start. And at that point, we exit the method in order not to block the thread. That's the first moment we exit the method. And then we would like that at a certain point, when the book has been loaded, the method load data is called again, but starting from this line, so that the text field shows all the information about the book. And then we will show info that the author is being loaded, start the loading, and here again we would like to exit the method. This is the second time we exit the method. And then when the author loading is finished, we want to call the method load data here once more, but now starting from this line. So there are three places from which the load data method execution can begin. The first time, before the book is loaded, the second after the book is loaded, and the third after the author is loaded. Let's make it so the method load data takes a step, from which the execution should start. Let it be of type int. And initially when this method is called, this should be the first step. Let's set it to have the default value of 0. And inside we add an expression when. Inside when we pass a step. And depending on which step is being executed, we perform different actions. If the step is equal to 0, then we need to set is enabled of the button to false. Set the text, saying that we are loading the book info. And then start the book loading. We don't perform any actions inside yet. That is, in the beginning, if the method is called with step 0, we perform the first action and exit the method. We don't work with it further. If the same method load data is called with step 1, and then the book has already been loaded, and we need to perform the next actions. Let's do it. If the variable step equals 1, we execute these actions. And then start loading the author. Don't worry yet that we're missing the variable book. We are still building the structure of the method. And if the author has been loaded, then we again need to call the same method load data, but with step 2, in which we will set the author's info and make the button active. We also add this step and move this code there. Then we delete all the other actions. Now initially when clicking the load data button, this function is called. Nothing is passed here as a parameter, so the step is set to the default value, which is 0. Then we make the button inactive, set the necessary text, and start book loading. After that we exit the method, in order not to block the thread. And then someone must call this method again, but with step 1. And this should be done at the moment when the book has been loaded. The method load book takes a callback as a parameter, and this callback is called right after the book has been loaded. So inside this callback, we can call the same method loadData and pass 1 as a step. Note that now we are repeating what happens inside suspend functions. I mean, we perform some actions sequentially, and at some point we exit the method. And when the loading finishes, the same method is called again, but now with step 1 rather than step 0. That means the actions in this method will execute starting from this line. The behavior is the same as with suspend functions. Next, if the function was called with step 1, we set the necessary text and start author loading. When the author is loaded, we again need to call the same function, but now with step 2. So we do that inside the callback. You're watching a video from our Kotlin programming course. I've left a link to the full version of the course as well as the biggest discount available in the video description and in the pinned comment. Enjoy watching. This is roughly how suspend functions look under the hood. But now notice that after the book has been loaded, in the second step, that is the step with index 1, we need to set the information about this book in the text field. And we also need to pass this book as a parameter into the method loadAuthor. That means the method loadData needs to accept not only the step, but also some data. In this case, the book. Let's do this. We pass the book as a second parameter, its type is book. But during the first call of loadData, the step is equal to 0 and no book has been loaded yet. That's why we don't need to pass this parameter at that point. Let's make it nullable and set its default value to null. Now let's see what happens. The function loadData will be called when clicking the button, and no parameters will be passed to it. Then step 0 will be used, and as the variable book will be set the value null, since it's still not used at this stage. In this step we start loading the book, and once the book is loaded, the method loadData will be called again, where we pass 1 as a step, and as a book we need to pass the loaded object. Let's pass it as a second parameter. We can refer to it using it. Why it? Because the method loadBook takes a lambda expression as a parameter, which in turn takes the type book as a parameter. It is the only parameter, so we can refer to it using it. And now when this function is called with step 1, we can be sure that the book variable holds some value, and we can work with it. For now, let's add exclamation marks. We'll fix it later. At this stage, we've set all the necessary information about the book in the text field, started loading the author, and now at step 2, we somehow need to pass the author. And to solve this task, we could pass to the function loadData another parameter author, and then use it. But that wouldn't be a very good solution, because there can be many such steps, and each of them may require its own data. Now think, what can we do that the function loadData takes only two parameters, the step and an object of some type, where we first can put the book and then the author, so that we don't have to create many variables, but calling the method loadData once, passing the book, and the second time, call the same method but pass the author. I hope you've guessed that this could be the type any. Let's use any instead of book. And let's rename the variable to reflect that this is some kind of data. We'll just name it data. So on the first call of the method loadData, the step will be 0, the data will be null, since it's not used. In this step we start loading the book, and when it's loaded, we call the method loadData again, passing 1 as a step, and the book as the data object. This function will be called again, and we'll get into the construction when, at this stage. So here's the variable data holds the book, and in order to work with it as a book, we need to do a downcast from type any to type book. Let's do this. We create a variable book, and assign it the value of data, cast to the type book. Now we no longer need double exclamation marks, because if the variable is still null, it can be cast to book, and the app will crash at this point. But this won't happen, because we are calling the function loadData with step 1, passing the loaded object we need. Then we load the author, pass the book, and when the author is loaded, we again call the function loadData. We pass 2 as a step, and as the loaded data we pass the author. We refer to it using it. Now once the author is loaded, this function will be called again with step 2, and the variable data will hold the author. We'll get in this block. And here we can get the author object by casting the variable data to type author. So this is roughly how the coroutines work under the hood. This topic is truly important to understand, because it's often asked about in interviews. The question usually sounds like this. How are suspend functions implemented? Why did Kotlin get the ability to exit a method somewhere in the middle, and then return to it not from the beginning? And now you can see that there is no magic here. In fact, programming using coroutines is the same as using callbacks, just hidden from the developer side. This approach is called state machine. We have a function that is launched with different states. One time it starts with step 0, then it starts again with step 1, but the data passed is the book. And then the same function is called with step 2, and the data passed is the author. In fact, there is no actual exiting the function somewhere in the middle and returning to it. We call the function with a certain state, perform an action, and here is the function finishes its work. But there is a callback here. That will call this same function again. It's already called with a different state, so the next call to this function will happen not in this block, but in the next one. And all these values, step and data, are stored in the continuation object. And if you look into the bytecode of a suspend function, let's open some file. In the package Coroutines, we open the class display. Here we have a suspend function loadbook, which doesn't take any parameters. Let's open the bytecode. We go to Tools, Kotlin, Show Kotlin bytecode, and decompile it into Java. We look for the method loadbook, and here you can see that in our case, loadbook didn't take any parameters. But under the hood, it accepts a continuation object. Then labels and the state machine are used here. The process of passing data is a bit more complicated here than what we did in our implementation, but the essence is about the same. A state machine with a transfer step and data. And at this point you should already clearly understand why suspend functions cannot be called just from anywhere. Only from coroutines or other suspend functions. Let's look at the code where coroutines are used. And imagine that there is no scope here. It's just sequential synchronous code. At this stage you know that this suspend function is in fact an ordinary function with a callback. When the book is loaded, the callback will trigger, and in this callback, the next actions will be performed. Here, if you don't use coroutines, there are no callbacks here. All our code is synchronous and runs line by line. So in this place, the program doesn't know what it should do. Should it block the thread until the method finishes, or somehow react differently to the call of this method? So from here you can see that Kotlin with coroutines only looks synchronous and sequential. But in reality all these actions are asynchronous. And that's why you cannot call a suspend function directly from a regular function. If all this is clear to you, then you can move on, where we'll continue studying coroutines. See you there.